now that we've had our introduction to logarithms in general, today I want to talk about a couple special logarithms. First, before we do that, I want to talk about something called Euler's number. It's also sometimes referred to as the natural number, and also sometimes referred to as the natural base. Just kind of depends on who you're talking to. But it is E. E is either Euler's number, the natural number, or the natural base, depending on who you are talking to. It's a lot like pi in the sense that while it is a symbol, it represents a specific value. It's not like x or y or some other variable that we may use where it could represent anything. You shouldn't really ever see someone using e to represent some random variable. E, much like pi, when shown in any type of math equation, should be referring to a very specific number. Also like pi, it is irrational, meaning it is a run-on decimal. So recognize these are the wavy equal signs here. These are the approximation signs, meaning Euler's number E is approximately equal to 2.71828, but it goes on for much, much longer than that. You cannot actually cut it off as a specific value. It is an irrational, it runs on, okay? Now moving past that, because I won't focus on how it's calculated or anything like that for this video, that can be a separate thing. Moving past that, the two special logs that I want to talk about today are the common logarithm and the natural logarithm. The common logarithm does not have anything to do with Euler's number at all. The common logarithm is just simply saying if you are given a log and there is not a base stated. So like here, it's just log of x, right? We talked about how to say logarithms, how to speak logarithms in the previous video. So it'd be log base something of x. If they don't show you a base, you would just say it's the log of x. And the assumption with that is if you don't specify a base, everyone is told to assume you must be referring to a log base 10. If you ever want to deal with a logarithm that is not base 10, you need to specify that base whenever you're saying it or when you're writing it. So if you ever give a log without stating a base, then it's assumed you're referring to a base 10 logarithm. That's the common logarithm. The other special log is the natural logarithm. That is shown as the ln of x. That is ln, to be clear. It's the natural log of x. It's kind of odd that it's ln and yet we would say natural log when we're saying it out loud, but that's how you do it. So we have the ln of x here, or the natural log of x is how you would actually say that. The natural log of x is equivalent to a log base e, Euler's number, of x. So that's why we discussed Euler's number at the top of this video, is that a natural log is a log that is using Euler's number as its base, which is also why Euler's number can be referred to as the natural number or the natural base, is because of its tie-in here with the natural log. So using these two, there's not a whole lot of different things that we can do with these logs that we haven't already talked about as far as other logs, but we'll still go through a couple examples here of just some things you can do to simplify expressions here. For example, let's say that I asked you to find me the natural log of e, Euler's number, to the 5th power. There is some interesting interplay between the natural log and the natural number, Euler's number e, because if we remember what we talked about in the last log video, we know that we can write any logarithmic equation as an exponential equation, at least assuming there's a single log. And so if we try and do that with this, well, we don't know what it equals, so just like before, we would want to set it equal to some variable because we don't know it yet. Generally, x is the commonly used variable. Instead of looking at it this way, let's consider what ln, the natural log, actually represents. As we just discussed, the natural log represents log base e, meaning what we really have here, if we're taking the natural log of e to the 5th, is we have the log base e of e to the 5th. And again, we don't know what that equals yet. Well, let's take this, now that we know the base of the log, let's put this into exponential form. So if the base of the log is e, then I'd also want to keep using e as a base. X, the thing that's by itself on the right side of the equation, would become the exponent for my base. And then this is going to be equal to whatever we were taking the log of. In this case, we were taking the log of e to the 5th power. Well, if we look at it in this form, in exponential form, I think it becomes much clearer what this is equal to. This is equal to 5, right? Because if I have e to some power is supposed to be equal to e to the 5th power, well, both of them have the same base, so for them to be equal, their exponents also need to be exactly the same. So x is equal to 5, meaning that if you are asked to take the natural log of e to the 5th, the answer is simply just the exponent, 5. Which is not really because they're canceling out like that slash line shows, but that is effectively what you end up with for an answer. It's almost as if the ln and the e went away, because they do somewhat neutralize each other just with their interplay in between there. Let's look at another example. Let's say I gave you e to the natural log of 4, and I wanted you to tell me what e to the natural log of 4 is. Well, that is in exponential form right now. We don't know what that equals. We may have a guess, but we don't know for sure what that equals. So again, we'll just set it equal to x, meaning we don't know yet. Let's rewrite this into logarithmic form, since it is in exponential form right now. Well, the base here is certainly this e, Euler's number, that has the exponent of the natural log of 4. So when we change this to logarithmic form, I'm going to make my log be base e. Again, the natural number, Euler's number. Since x is by itself on the right side of the equation, that means I'd be moving it over to be what I'm taking the log of in my logarithmic form. And then that would mean it has to be equal to whatever my exponent was, which in this case was the natural log of 4. Well, we have just talked about the fact that log base e is literally the natural log, ln. So I could rewrite this, instead of log base e of x, as the natural log ln of x. Well, if the natural log of x is meant to be equal to the natural log of 4, they're both the natural log, meaning they're both logs with the same bases, so that means I have to be taking the log of the same number on each side for them to be equivalent. So that means x must be equal to 4. Or, much like the other one, it's almost as if the natural log and the natural number just neutralize each other, giving us simply 4 as our answer. That's some of the interesting things you can have when you start messing around with the natural log and trying to solve out some expressions, some equations with that.